All right, girls and boys, we are going to continue our lesson on fractions. And today we're going to focus on fractions and models when the denominator does not match the amount of equal parts. And what I mean by that is sometimes you'll have fractions where it works out perfectly where the denominator does match. So this egg carton here, it's a 2x6 array. There are 12 eggs. So any fraction with a 12 as the denominator, the bottom number, is going to work out perfectly. If I needed to show 7/12, I would simply shade in 7 eggs. So here's 6, here's 7. That's 7/12. This denominator, this 12, matched the amount of equal parts. But when it does not match, that's where fractions get confusing. Now, an easy example of one where the denominator doesn't match would be a half. Okay, if I wanted to show a half of an egg carton, well, for half, my denominator is 2. If we look at how many rows there are, there's 2 rows. 2 rows with 6 columns. So 2 rows of 6, I would simply divide it into 2 equal parts before I shade, and then just shade in one of those equal parts. So you have to make your group of equal parts match the denominator. So right now I'm going to shade in one of my 2 rows, which I just shaded in 6 eggs, 6 out of the 12 eggs to match the half. I had to do the work up front, dividing my total amount of parts into the parts that my denominator demands. So we could also show this linearly on the ruler down here. I just cut it right down the middle. I visually see I cut it into 2 equal parts. If I wanted to know what a half would be, I would just make one jump. And then I have another model down here. It's a 4x6 array, which is it's 24 squares. So if I cut it down the middle this way, I've created 2 equal parts. And if I wanted to shade in a half of my 24 squares, you guessed it, I'm shading in 12 of the 24 squares. That's a half. Okay, so that one was probably the easiest one because everybody knows what half means. Quarters now. Quarters, you probably remember from previous lessons, a quarter is half of a half. So if we already have this cut down the middle, cut it down this way, and 1/4 would be this corner up here. So it would be 3 out of the 12. If we wanted 2/4, which is the same as a half, that would be 2/4. This represents 3/4. So 3, 6, 9. 9/12 is the same as 3/4. A half of a half, that's what a quarter is. So on a ruler, here's my half right here. If I cut my first half in half and cut my second half in half, now we're talking quarters. 1/4, 2/4, 3/4, 4/4. So 3/4 would be 9 inches. 9 inches is 3/4 of a foot. And then if we take a look at this array, this is a 4x6 array, 24 equal parts. And if I wanted to show quarters, well, I need to divide this into 4 equal parts. If I look at how many rows there are, it's naturally divided into 4 equal parts because there's 4 rows. So I would just draw lines here separating each one of these rows. And for fourths, 1/4, I would just shade in this whole row. 2/4, I'd shade in this row, which that means each row has 6, right? So 6, 12. So 12 24ths is 2/4, which is the half. 3/4 is 18 24ths. And a step further, if I wanted to show 8s, well, we can't really show 8s on on an egg carton because 8 doesn't go evenly into 12. It skips right over. It goes 8 to 16, so you can't do 8s on here. So I would have to pick the correct model. The best model would be the 24ths model because I know an 8th is half of a fourth, and a fourth is half of a half. So let's cut it in half. And then we're going to cut each half in half to get our fourths. And then in order to cut our model into 8 equal parts, we already have it cut in 4. So now I'm going to cut this fourth in half, this fourth in half, this fourth in half, and this fourth in half in one swoop. And now we have 1, 2, 3, 4, 5, 6, 7, 8. 8 equal parts. So if I needed to show 8s, I could do like here's 1 8, here's 2 8s. So obviously each 8th is 3 24s. 3 8s, 4 8s, 5 8s, and so on, all the way up to 8 8s, which would be the whole thing. And next, we're going to talk about thirds. Thirds kind of beat to a different drum. There's not 3 equal parts, or there's not 3, there's not 3 equal parts, there's not 3 rows, there's not 3 columns. I do this little trick for thirds where I find the middle and I put my 2 pointer fingers, one from each hand, pointing right in the middle, and then I slowly separate my fingers, one going this way and one going that way, apart from each other, until it looks like I get to a point where if I've made a tick with both fingers, it looks like there's 1, 2, 3 equal parts. So I have just divided this egg carton into 3 equal parts. And if I counted the amount of eggs in each, it's all the same number, so I know I did it correctly. So 4 of these eggs would equal 1/3. And I could use that same trick for any type of linear model. You find the middle, but you don't make a tick, and then you start separating your fingers away from each other. This one this way, this one this way, until it gets to a point where they all three chunks look about the same. Now you have your thirds. Here's 1/3. Here's 2/3. So 8 out of 12 is 2/3. There's the whole thing, thirds. So this one is not divided into 3 rows or 3 columns, but I still need to do thirds. So we could do that same trick, moving this way and moving this way. You get to about here, and there's our thirds. If I shaded in one of those chunks, including all the rectangles or the squares in it. 1, 2, 3, 4. So there's 8 here. 8 24ths is 1/3. So now sixths are actually half of thirds. So I'm going to leave my thirds up to help me with 6. If I need to divide this model up into sixths, well, here's my thirds. If I remember with my thirds, I can easily transfer that into sixths by simply cutting each third in half. And another thing about this is an egg carton has 6 columns already. So sixths are naturally built in. It's already divided up into 6 equal parts. So here's 1/6, here's 2/6, here's 3/6. Every time I fill in one of these columns, it's another sixth. So 1, 2, 3, 4. That's an example of 4/6. I could go 5, I could go 6/6. For my, actually, I'll just put that back. That doesn't really make a difference. For my ruler, if I wanted to show 6, I got to cut it back into thirds, just like we talked about, and then cut my third in half, this third in half, and this third in half. So 1/6, 2/6, 3/6, 4/6. Did I do that right? 1, 2, 3, 4, 5/6, 6/6. Okay. And here, this also has 6 columns, so I would cut it into 6 equal parts this way. Or if I already had it cut into thirds, you could even do it this way and then cut each third in half like that. Those are sixths. Every 4 squares on this model is 1 more sixth. There's 2 sixths. There's 3 sixths or half. There's 4 sixths. Here's 5 sixths. Here's 6 sixths. So that's how we do our sixths. Twelfths is pretty straightforward when we're talking about our egg carton, because the for 1/12, the 12 actually matches the amount of equal parts. So twelfths are simple. 1/12, 2/12. Same thing with our ruler. 1/12, 2/12, 3/12. This one, not so much. It's not that tricky, but it doesn't match. So you would need to divvy this into 12 equal parts before you could show twelfths. Well, we know there's 24 of them. Another little tip about twelfths is a twelfth is half of a sixth. So to make 6, we have to find thirds. So thirds, and then here's our sixths. Well, we have 6 columns actually. And then if we cut each sixth in half, now we have twelfths. So now I'm all set to represent my twelfths. Here's 1/12, here's 2/12, here's 3/12. So each twelfth is 2 24ths. Here's 4 24ths or 2 12ths. Here's 3 24ths, which is 6 12ths, or 3 12ths, which is 6 24ths. Here is another 12. So that's 4 12ths, which happens to be 8 24ths. And 24ths, well, the model with the egg carton and the ruler isn't probably the best one for 24ths. However, the model that already is divided into 24 equal parts works the best for this one. So if I needed to show 24ths on my 4x6 array, I would just simply do 1 out of the 24, because there's already 24 squares. I already knew that. If I wanted to compare fractions, it's a matter of choosing the best model that works for both the denominators. So for this one, 3/4 compared to 5/8, well, I already know eighths does not go into twelfths. My egg carton is not good for eighths. It's good for fourths, but not for eighths. So I'm going to have to do these on this number line. I'm going to find fourths first. I'm going to cut my number line in half, cut this half in half, cut this half in half, and then I'm going to label 3/4 on here. 3/4, because it was 1, 2, 3 out of 1, 2, 3, 4. Now eighths, an eighth is a half of a fourth. So cut that fourth in half, that fourth in half, that fourth in half, that fourth in half. So now we have 1, 2, 3, 4, 5, 6, 7, 8. And if I wanted to go to 5, 1, 2, 3, 4, 5. Here's 5/8. And now we can see that from the distance from the 0 all the way to here is greater than the distance from 0 to here. So 3/4 is larger. And the next one, 1/4 compared to 1/6. Well, let me see. Sixths and fourths both fit on the egg cart. Okay, so let's do 1/4 first. I think we've cut it in half for fourths and then cut each half in half. So this would be 1/4, right? So it's like 3 out of the dozen. So 3/12 is 1/4. Okay, so now sixths don't really go with fourths. So I'm going to erase my mess right here. And now I'm going to go back at it and see how many eggs 1/6 is. So I remember cutting for 6, you need thirds. But actually, there are 6 columns in here, so but the same thing, cutting each third in half is a sixth. And so 1/6 is 2 of the eggs. So 1/6 is 2/12. So which is larger, 3/12 or 2/12? Well, 3 eggs is larger than 2 eggs. So 1/4 is larger than 1/6. So that's how we choose the right model and represent fractions that don't match up, where the denominator is different. And it's also how you can compare fractions. So come back and watch this video again if you get caught up or mixed up, and good luck.